the networking community meeting, Istio networking community meeting, and we have two items today on the agenda. The first item is controlling policy governance with Istio authorization, and I'm not sure if Limin is on the line, or maybe she'll join us later in the room. And the second item is Istio-pod-network-controller, and I saw Rafael joining, so I maybe will just switch the order and cover this in the beginning. Meanwhile, could you please add your names to the attendees, and let's see if we can get started with the second item. So Rafael and Andrew, I saw you joining. Are you able to speak first?
Sure. We can start.
Oh, okay. We actually just changed because you weren't here, we changed the order. Is it okay to go second?
Oh, actually, can I go first? I have another meeting at 11.
Okay.
30.
Are you, Rafael and Andrew, are you okay to maintain the original order?
Sure.
Okay,
Yeah,
thank you.
Yeah, sorry for that. Yeah.
Yeah.
So I need to go to another meeting for the second half.
Thank you.
Thanks. So let me present the proposal. Oh, actually, I don't have the meeting invite. Can you present?
Sure.
Yeah. Can I borrow your laptop?
Okay.
Yeah, so I can start introduction. So this proposal is about using Istio authorization to control who can edit or view Istio policies. So today, yes, okay, next. So Istio policies are currently expressed in the form of Kubernetes CRDs, and we currently use the Kubernetes RBAC to control who can edit or view a particular Istio policy. So for example, Istio authentication policy and the authorization policy all use the namespace as the scope to determine policy ownership. And so this model has the advantage of, so it fully utilizes what platform provider. The Kubernetes provides all the control. Kubernetes RBAC provides all the control. On the other hand, it also has some limitations. First, it does not apply to the resources like workload or hosts, which is unrelated to namespaces, and it can cross multiple namespaces or be a finer-grained object inside the namespace. And the other limitation is it does not apply to a non-Kubernetes platform. In that case, the namespace concept does not apply. Yeah, so I read there was another proposal, traffic ownership proposal, which proposed to solve this problem by creating association between the Istio objects like hosts or workloads with the namespace. And so this is just another alternative we can do. And I think it provides more flexibility.
Okay.
Yeah, so here are the goals. We try to provide access control for who can edit and who can view Istio policy at different levels, like workload level, host level, namespace level, or mesh global. And we want to have the authorization work across the platform. So basically, it can work for Kubernetes platform and the non-Kubernetes platform. And the access control should apply to all Istio policies. And we want to provide a consistent policy configuration interface for Kubernetes and Istio users.
Mm-hmm. So in the context of virtual service, we had this problem of having separate ownership for like different, let's say, different like path belonging to different owners, but for the same host.
Okay.
So how could we solve this with RBAC?
Yeah, actually, yeah. If you I can talk about the detailed proposal.
Oh, okay.
So you can see actually I include the path.
Okay, so you have a concrete example then.
Yeah.
Excellent, yeah.
Yeah, I don't know if I actually have the path example, but it's part of the parameter.
Okay,
yeah.
Great.
Yeah, so the proposal is to introduce two new objects called the operator role and operator role binding. The operator role specifies the resources or sub-resources an operator is allowed to configure or view. The operator role binding assigns an operator role to a list of subjects. So here's the definition of operator role. Operator role can include a list of rules. Each rule is a permission. So each rule can include the following entries: the API group, for example, networking.istio.io or authentication.istio.io. So it should all end with istio.io because we only talk about the Istio policies. And resources are the CRD kind of Istio config objects like virtual services, virtual service, gateway, service entry. If this entry is not, if resources is not specified, it applies to all resources in the API group. And hosts. So within, so for a particular resource, you can specify hosts. For example, it applies to star.example.com. Yeah. And it can also, the same host entry can also express the namespace scope. So for example, ns1 namespace can be expressed as star.ns1.sbc.class.local.
Mm-hmm.
And the other entry is IP addresses. So you can specify the IP address and also path. Path can refer to the virtual service URL, what you just mentioned.
Okay.
And to be clear, the IP address in this context is the service entry address that we use for virtual IP addresses.
IP address. I believe several networking objects has an IP address. Virtual service has one.
The service entry, and I think probably virtual service also has one.
Yeah. Okay. Perfect. Just wanted to make sure that was yeah.
Oh, okay. Yeah, I'm not very too familiar with the networking objects. And also ports. You may also want to specify the ports. And verbs. Ports. Like
so can you separate, have like separate policies for each port?
Yeah.
Okay.
Yeah, that's why we have an entry here. And also verbs. Verbs can include the get list or create, update, delete. So it includes the read operations and the write operations. Yeah, so here are the exact meaning of the hosts. Like for virtual service, it refers to a host entry. Yeah. So I don't want to read all of this. Basically, for different different CRD definition, there are different hosts entry there. So this is an example of operator role definition of networking admin. So the name of the role is a network admin, and so for networking admin, he's allowed to configure networking.istio.io API group for all the resources. Basically, I can even skip the resource part. And just for this particular hosts, star.example.com. And this is another example, which is a security admin for NS1. Yeah, actually the same functionality today is already provided for security policies because we already use namespace. So this example is using namespace, which is you can see the host entry is star.ns1.sbc.class.local. So this is so the security admin is allowed to configure security policies for NS1 namespace. That's what it means.
Right. So the namespace itself is not a first-class concept. It's just baked into the host.
Right.
If I am to refer to the host by the DNS name, I would not have a namespace necessarily, right? Like if my host is called bookinfo.com,
Oh, okay.
how would I use the namespace in this situation?
In that case, there's no namespace.
Okay.
If we're gonna, so I'm not totally sure that we can do that method to restrict namespaces in general. I think we might need a namespace field specifically if that is what we're trying to do. I also kind of worry it's a little bit of an abuse of the semantics. That's not really what host means there, right? And it just so happens that the namespace as a concept is encoded in the DNS name. But anyway, that's it. That was the only part that stood out to me is a little fishy.
I see.
Right.
I see. So it's not really true. This host represent all the namespace.
Yeah, exactly. It's a bit overloaded semantics.
I see.
Yeah, but I think let's hear the entire proposal because we had also like different alternative, and then I guess the community will probably decide, which one is the way to go.
Yeah,
and then we'll make it better. Just add options to it and all that, right?
Yeah, that's right. Yeah, and also you can support the finer-grained access control, like the host can specify a particular service.
And so do these policy apply hierarchically? Like if I have a policy that says star and another policy, they do.
That's
okay.
when I'm coming next. Yeah.
All right, perfect. Yeah, sorry if I should have.
And we also want to support like a prefix match and a suffix match in the host and the path. So operator role binding is actually very similar to the current Istio service role binding, or it's also similar to the Kubernetes role binding. So it has two parts. One is the subjects. It's a list of subjects which you bind to this role, and the other part is the role ref, which refer to the role definition. You can refer to the network admin role, for example. Potentially we can probably, instead of defining two different type of operator role binding and service role binding, we can just use a single role binding object, which apply to both, because the definition is basically the same.
I actually think that the role binding is closer to the Kubernetes role binding than it is to the service role binding, because here when we're talking about users and groups, we're talking about that specifically from the perspective of what the Kubernetes API server understands, right?
Yes. Yeah.
Okay.
Yeah. So the user info will come from Kubernetes, will be provided by Kubernetes API server.
But that means that people will have to have what about the user-based authentication with Kubernetes, right?
Yes. Yeah.
Is that a widespread thing that is always going to be there, or is that going to be?
I mean, it's basically table stakes if you're doing any kind of access control over Istio the way that it is today, right?
Yeah, basically, we just don't have an answer for identity in this context outside of Kubernetes today. Does Istio RBAC in general actually work outside of Kubernetes?
No.
Yeah,
It doesn't?
Or
do you have plans?
Istio RBAC? What do you mean?
Like if there is no Kubernetes, how would we apply these concepts in some other platform? Let's say VMs running with.
But Kubernetes API server will always be there. So I think there is a.
So that needs to live in Galley, not Kubernetes API server, right?
Well, this is access control over configuration. So when we're talking about subjects here, we're talking about subjects who have access to change Istio's configuration, not about subjects who have access to particular services that are sort of in the mesh.
Yeah, totally.
If we integrate with something as, I don't know, Active Directory or like some other systems, for instance, would they be able to enforce this? Would we be able to get the, some user account or?
Yeah, but wouldn't they have their own of access control? I know Cloud
Why
Foundry has
would-
their.
Yeah, but
Why
I mean,
would
the
I
point
not
is
be
this
able to
has to be.
use Istio access
so-
control if I'm not on, like, this is
Because this
Istio
is-
access control, not Kubernetes access
No,
control.
but the
I-
problem
I would
here.
argue that this is Kubernetes access control for Istio, just like Cloud Foundry today. I believe they have some access control.
Right,
without
but
anything
what I'm
we've
saying
done.
is the problem now is not about the access control. The problem is to have this at the point of config ingestion. So this is not like, I mean, if this is in Kubernetes, this is at the lowest level of the stack. When somebody is defining this through the CF APIs and so on, we are not going to be able to catch this. It's all probably going to be coming through like one galley user always. That's it. And the same thing applies in any other CI/CD context. This will apply only in the expert use scenarios where people are actually directly interacting with Kubernetes to write their entire configuration, and then people have like everybody has an account, as Spike said, and then in that case, yes, great. But imagine something like Fabricate or like any of those entire infrastructure that you actually overlay on top of Kubernetes. In those cases, the problem is still not solved because the problem just gets punted over to somebody else, because those CI/CD systems are going to be the only users that are going to be generating these resources.
Yeah. Well, so you can still mint different accounts for a CI/CD system to use, but my overarching point was this: enforcement of this should live in Galley, and how you get the user identities needs to be pluggable.
Yeah.
That's the answer to decoupling it from.
Yeah. So
Right.
so actually, if you look at the implementation, it is a plugin in
Perfect.
Galley. And if there is a Kubernetes API server, then we just add an
Mhm.
additional webhook.
Perfect.
So one suggestion that I had is, instead of having a laundry list of all the attributes that an operator can define, like hosts, IP addresses, and so on, if you scroll down towards the end of this document, I added a suggestion, which I don't know if it's actually going to show up, but yeah, so that's the suggestion that I have. So it's more of like, this makes it a little bit more generic in the sense that it can actually apply to everything other than just networking as well, where you define a template of some sort, where the fields can actually have, whether this section is allowed or denied by this operator role. And that would probably make things a lot more scalable in the longer run, because as we introduce new objects, which has newer attributes, and so on and so forth, and this also applies equally well to mixer configurations and or even the own RBAC configuration itself. Galley would simply have to run through this template, like where it actually looks at the individual fields and then sees if that's actually being overwritten by the incoming config, and if that actually override is allowed or not.
Yeah. So so this is one possible approach. And also I was also thinking of like similarly, I was adding to the service role for the exclusion semantics for the deny, what you mentioned.
No, so this is more like, the template is actually like a complete, I don't know, protobuf struct or whatever it is that you happen to call it. The point being that this operator role will no longer have any idea of whether you're applying this role, the role is applicable for IP addresses, hosts, addresses, and so on and so forth, because these are things that are very, very specific to the networking CRDs. And if you go and take this and like this list will go too big. And then if you want to apply this for mixer stuff, then there'll be a whole bunch of other things that come in, and we'll just have way too many attributes. It just becomes unusable. Instead, if you just create this as a very generic template of something where you supply a blob, like the way we do validation today, right? So like Pilot has a validation file which has all the validation stuff. Mixer probably has something similar. So we get to write that stuff, and the semantics of that proto thing is, I don't know, fully enclosed within Pilot, Mixer, Citadel, and so on and so forth. They take in the blob, and then they take in the template, and then say this is allowed or denied. That's it. So then the system that's enforcing this will become much more simpler and easier to maintain in the longer run.
Okay. Yeah.
So would we be able to model something like, for this role, allow all the permissions, but deny permission to edit this particular resource or field?
Yes.
Yeah.
Yes. So something very similar would be like
or exclude semantics.
Right. Yeah. But basically this will also encompass a traffic ownership proposal, where we say that hosts star.foo.com cannot be modified. It's always read only, but people can define something under star.foo.com with they can only add additional HTTP rules or with these paths and so on. And at the same time, you can also define that nobody can define something like host star.com. You can actually go do an outright deny. which would actually allow this. It should encompass the use cases that the traffic ownership proposal has, like who can capture wildcards and who cannot capture wildcards. And if we have this way, then the nicer property is that we can do some form of inheritance in the destination rule, where somebody can define a global destination rule which says MTLS everywhere for all clients, and we can have the inheritance semantic where we can actually set up this RBAC rule that says nobody can overwrite the TLS field in a destination rule for internal hosts. And then we would be guaranteed that like every destination rule that user supplies will not have the TLS field at all. We can always inherit directly from the global thing. Today, the problem is that we can't do this because inheritance is not defined, because we can have user can define a local destination rule and a global one, and things are just
so I do not want us to couple the notion of access control with the notion of default configuration. Those should be two separate things.
We're not going to coupling it. So what I'm saying is, if we have this in place, then we would know that any destination rule that comes in will not have a TLS field set, which means there is no conflict in merging with the parent rule, and that becomes an easier one. And the same thing can be applied in other scenarios where somebody wants to define a global rewrite across all virtual services. Today, we can't implement that because inheriting a virtual service like from star.com to star.foo.com to star.bar.foo.com is complicated. What happens if there are conflicts in the same field and so on? But with this, we can actually go fine grain and say, you know what, if you only the root can actually do that global rewrite and everybody else has to simply inherit that field, nothing else can actually be done. And see what I'm saying? So this can actually become, it's more than just like allow or deny, it could actually become an inherit as well. But it just
so by the way, the templates is it can it be reused or is just defined here? Defined for every policy.
So
it is defined for every resource type, basically. So for virtual service, you have, I mean, this template is the same proto that virtual service has. We probably go and add that RBAC field or whatever it is to all the places that could potentially have inheritance. Or
well, there's a couple of different strategies that we
I'm hand waving, but you get the idea.
Yeah, so like we could use field masks to achieve the same thing. That's a horrible API, but it's the same semantics as one way to do that. So you could just the binding itself or this rule itself could just be a list of strings or a list of field masks that target the fields of the virtual service. Or you could, like Sriram suggested, do like a CRD per object in the API. Yeah, per resource.
So if this were a very generic, instead of having hosts and IP addresses and all that separate, then you would have a field, like the ability to restrict modification of a field that the user would define. And we could in this case, we could disable access to like TLS settings, right? But it would not be baked into the implementation of the policy. It would be something that the user, configures.
So I mean, I would go as far as saying that all we need is operator role and operator role binding, and then in every CRD that we currently have in Istio, and in places where that could actually be overridden and whatever it is, we have to add a field in every the substruct that says like RBAC mode is allow deny. It's an enum that we actually have to add, so that when people whatever template that people define here would actually be that the whole thing.
I don't want us to couple our API definitions with RBAC stuff. Like those are two independent concerns: the objects themselves and the policies over the objects. Like if we want to do this kind of generic stuff over top, I think we can totally do that. But we can do it in a way that doesn't require us to change the actual Istio API objects themselves.
I don't think he meant changing the API. Maybe you were referring to the implementation, Sriram, right? Because we don't need to change the API for that.
No, I had thought of like changing the API where we actually add additional RBAC fields, and then which will be like not used when people define the stuff, but they'll be only used in this template mode. But Zach is right. We can do it in other ways as well. We don't have to couple them. But this is more portable across other Istio resources.
Right. And RBAC is an add-on. Like there would be too much complexity for the casual user if they have to think about, do I want RBAC or not? What is this RBAC, right? So we want to start simple and add features on top. Just like we had security or telemetry or RBAC, fine-grained control of policies. So.
Yeah, that's that one. Yeah.
Yeah. Okay. Let me continue on what we left. So you can enable this operator authorization on a particular namespace, or you can enable it for all the supported resources. Basically, include all the Istio configurations. So this is actually the same semantics as what current Istio RBAC has. We have mode, which includes on, off, or on with inclusion, or on with exclusion. So on with exclusion basically has the whitelisted namespaces or resources, yeah. And on with exclusion basically blacklist the resources that should not be authorized through the Istio authorization. And here is an example. So we use the mode on with inclusion, and the inclusion list include networking policies. And I also added the operator role and operator role binding itself in the inclusion list because I want to support the permission delegation, which I will talk about next. So for hosts and IP addresses, they have the natural hierarchy. Yeah, actually, Andrew already mentioned this.
Yeah, that was one of the things we needed. So.
Yeah, so basically, we can use Kubernetes RBAC to bootstrap to create the mesh level network admin or security admin. So for example, you can create this operator role, which is called a global network admin, which apply to the entire mesh. And this should be created through Kubernetes RBAC, controlled by Kubernetes RBAC. And after that, the global network admin can in turn create the sub-admin. For example, they can create the network admin for star.example.com. So you can just include the host entry here. And you can, so for the example.com, network admin can further create another operator role, which is called network admin for example finance. So it only applies to star.finance.example.com. So similar to IP addresses. So the general rule is an identity is allowed to create or edit an operator role or operator role binding if and only if he has all the permissions that in the if he has all the permissions that are in the to be created role and role binding.
Mm-hmm.
Yeah, so here I was saying in the initial offering, maybe we can just let Kubernetes RBAC to control all the creation or editing for operator role and operator role binding, and then add the hierarchical support later.
Mm-hmm.
So how does this Istio operator role and role binding interact with Kubernetes RBAC? So first, if you for the resources that you want it to be controlled by Istio authorization, you should exclude it from Kubernetes RBAC policy. You don't want to apply two controls because it will just be confusing and it may conflict.
Mm-hmm. And
also for the operator role and the operator role binding, if the permission delegation is not supported or used, then all the operator role and operator role binding should be controlled by Kubernetes RBAC. If we support permission delegation, then we should use Kubernetes RBAC to bootstrap, basically create the mesh level operator role and role binding. And after that, the control should be switched to Istio authorization.
Mm-hmm.
So you use the operator role and operator role binding itself to control who can create additional role. Yeah, so here is the proposed implementation. So we want to implement this operator authorization engine inside Galley. And the the input to the authorization engine will be the operator role and operator role binding and the other Istio config objects, which we want to control. And we want to have two plugins. One is the authorization webhook. The other is the admission control webhook. The reason we need two is because admission control webhook actually does not support the read operation. So all the operation will be authorized through authorization webhook. And the webhook will send a subject access review request to the authorization engine inside Galley. And for the write requests, there will be additional admission control review request, which will contain the to be modified object, which is not included in the authorization webhook request.
Okay. So I want to clarify a few things. So for this this to work, we need Galley, right? So because obviously the plugin is in Galley, and what is the current status of RBAC in general? So let's say we have like some basic RBAC functioning, and we need to add the new operators and operator roles, like the resource that you described in the document. But other than that, there is already some. Is there already a plugin in Galley that performs some like RBAC functionality?
Yeah, the current RBAC is supporting the runtime authorization. It's actually a different module from this one.
Oh, okay. So that would be a brand new thing in Galley.
Yes.
Okay.
Yeah. It's so the current RBAC works on the Envoy sidecar. It's authorized the runtime requests. But what we proposed here is to add a config time authorization.
Okay.
And that module needs to be plugged into Galley.
So, Liming, I have a quick question. So, does this also apply to the authentication policy? Also, you gave the example on the networking rules.
Yeah, we can. Authentication policy, currently we use Kubernetes RBAC to apply namespace scoped access control. But of course, if you want finer grain or other levels, you can apply Istio authorization as well.
Yeah,
so this applies to authentication policy.
So it does apply. I'm trying to understand from a user perspective, would they be using operator role when they see, the API version is Istio.io in their config? Then they would be thinking about using operator role and operator role binding to control the authorization, or do we? I mean, how does the user know when to use Kubernetes RBAC with Istio authorization? I think that's not super clear.
Yeah, so I think the guideline we should give is to user is if the current namespace-based authorization is enough, which is provided by Kubernetes RBAC, is enough, then they should just stay with Kubernetes RBAC. But if it's if they want a finer grain, like they actually want namespace level access control, or if they are running on non-Kubernetes platform, they don't naturally have the namespace. Or if, for example, for the networking policy, they have host concept, which namespace cannot restrict, then they should use Istio operator role and operator role binding.
Okay.
Yeah, it's probably useful to include that guidance in the doc.
Yeah.
Okay.
I think that would be really good.
Yeah. Are there any other questions on RBAC? Because we'll have to go to the next topic.
Yes.
I just want to make one note on the implementation that relies on the authorization webhook. That will require restarting the API server and passing that webhook configuration to it. Essentially, you tie the lifecycle of Galley to the lifecycle of the API server, which I don't think we want to do.
Well, I mean, that sounds like that's actually just broken in upstream Kubernetes. I mean, like, I understand why they might want to do that, to tie the lifecycle of their API server to whatever's doing authorization.
I think people want to fix it. It doesn't work today. That's my point. So
Yeah,
if we go off and do this, it's not going to work practically.
That's a
And-
very good
but
point. Yeah.
Authorization is only required for read restriction, right?
Yeah.
Right.
If
We,
you-
we can do
Yeah.
we
If
can
you only
restrict
care
write.
about write, then you just do admission control. If you
Yeah.
care about controlling who can read, then you need
Yeah, so that's a
authorization
good
of
catch, Jason. So it sounds like we can like go file issues upstream in Kubernetes, maybe get some of our friends around the corner from y'all to help, and then ship like read as a second phase.
Yeah.
Yeah,
Yeah,
that
just
seems
do the
reasonable.
admission. Ship the other access first, and then we can get that later.
Okay. Any other question? Burning question that cannot be answered offline in the document? Okay, so I think we got a very good overview, like pretty detailed, in fact, and we need to leave some time to people to like evaluate the proposal, and also like look at the other proposal, and we'll probably make a decision as a community.
Right.
And at some point, like if this is the way we will solve the problems with the virtual services hierarchy. And I think people will get into more detail into commenting on the API here. So
Yeah.
yeah.
Please comment on the doc if you have further comments or further feedbacks.
Okay, great.
Yeah. Okay.
Thank you very much.
Thank you.
Yeah. So I think we can move to the second item, which is the Istio-pod-network-controller. I hope, Rafael and Andrew, that you are still here.
Yes.
Okay, great. Thank you. So please feel free to present. I know, like we reviewed last time, you had some slides, so
Yeah. How do I take ownership of the screen? Oh, yeah.
I think you just like in the meeting, you choose I can stop presenting also. I'm not sure if that will help.
I think.
Yeah, we're seeing something. That must be you there.
Yeah.
Yeah.
Okay. Yeah, so if you remember, I think it was more than a month ago, I presented this idea that Andrew and I have been developing. What we are trying to do is to increase the security of Istio by removing the need of running a privileged container. And the container that needs to be privileged today is the init container, the one that sets up the IP table rules. So tell me if you want me to go again through the technical description of this proposal. My intention today was give you a status update of where we are, and then talk about a possible PR to the project, to the main Istio repo.
Okay, I think that sounds good. Does anybody need a short overview? Okay, I think we can probably skip the overview because people still remember from the last meeting, and we only have like 20 minutes.
Right. So last time we had these open issues, and I want to tell you how we addressed them. So for the first one was, how do we know that a pod should belong to the mesh, and therefore the daemon set which sets up the IP tables should actually act on that pod. And what we decided to do was to add an annotation to the pod that works in a similar way to the annotation that says if a pod should be injected with the admission controller. So unfortunately, it cannot be the same annotation because we have slightly different logic, but it's an additional annotation that works the same way. And then the second was it's a Docker. We need to do some interaction with the pod namespace. So that piece is container runtime independent. And the last time we only had a Docker implementation working, and so we now introduced a CRI-O implementation. It should be CRI compliant, but I haven't tested with any other CRI implementations except CRI-O. So I can only say right now the project works with both Docker and CRI-O as the container runtime. And yeah. Question?
So CRI, that's container runtime interface. So that would be the layer that abstracts from the actual container runtime, right? So
Correct.
You should be able to use Docker and Rocket and other like runtimes with CRI.
Yeah, that's true. Although for Docker we kept the current Docker specific implementation.
Oh, I see.
Yeah. But you're right. And then the third point is we didn't have last time an explicit synchronization between the pods and the container starting in the pod and the daemon set, which sets up the IP table rules. So we introduced an ini container that it's not privileged, but it waits for the IP table rules to be set up. So right now we have full synchronization.
So where is the init container? It's in the controller pod?
Init container is in the pod that will join the mesh.
Like in every pod, you mean? There's still an init container?
There is still an init container. It's just not privileged, and it's injected, transparently through the normal injection, mechanism. We just changed the injection config map to inject our container instead of the current one.
And how do you wait for the IP tables? How do you know they've been configured?
We annotate the pod when the pod that needs to join the mesh with an annotation once it's completely initialized, and the init container reads that annotation as a config map mounted to the pod.
Mm-hmm. But so the pod can be also annotated by some other actors, right? If it's not like protected, anybody can add an annotation.
Sure.
Well, I mean, you could even just treat the existence of the init container, which is going to trigger the network initialization as the annotation, right? You're logically what that init container is doing is saying, join the mesh, right?
So what the init container, yeah, sure, it could do that. I see what you mean. The init container could annotate the pod. The problem is we didn't want to give any privilege to the init container. So instead, if it needs to be able to annotate the pod, it now needs a grant on the Kubernetes API. We didn't want to do that.
But I thought you used the init container to check if the pod has been annotated by the pod controller.
What's the point of that?
So the purpose is to see that the IP tables have been configured by some other entity, which is the pod controller, runs outside of the application pod. Right, so they need they need a way to signal that this has been done.
Right. Let me see if this. So
I'm not sure annotation is like.
Right. I mean, logically, you can have the init container go, "Hey, daemon thing, add me to the mesh," and the daemon says you're added or you're not.
But how do you do this? A daemon add me to the mesh without granting any permission to the init container?
By making an API call to it.
To what?
To the daemon.
To the daemon, yeah.
All right, so let's say that the daemon's running on the node, it's listening on a domain socket or a port, that's node local, right? The init container boots, it calls it.
Yeah, so it's probably less trivial implementation than using the annotation, like checking for an annotation, but I think it's also a bit safer because you can have anybody, like any bad actor, annotating the pod and then just like bypassing the entire IP table stuff.
Right, so I mean, obviously the init container requires no privilege. The contents of that API, right, can be evolved over time to support more complex use cases around initialization, which might be useful. Right, so really the goal here is obviously to push the complexity, the network initialization down into something that's already privileged.
Yeah.
Right, by the daemon. So, yeah, I mean, and the init container can wait for the network or it can error, right?
Right, and in fact, that pod network controller in the future may do other stuff than just configure IP tables. right? Like if need be.
Yeah, it can do all
because
kinds.
the same mechanism would be used.
Right, but the pod doesn't need to know that.
Right.
Nothing in
right.
the pod needs to know that at all.
All right. I like the direction, but I'm just trying to think out. So these are the actors, right? You're saying this mesh pod as an any container that calls the network controller.
Yes.
It would have to call the network controller on the same node.
Yes.
But how do we do that in Kubernetes? Right.
Well, we can have domain socket, right? There are plenty of examples of other people having daemon sets that are being called by the node, by pods.
What privileges do you need actually for this?
None.
None.
That's just a network call.
Okay.
Right. The only thing you have to worry about is the security of it, right? Can it be spoofed or not?
Well, you
But
can use TLS for that,
Right.
like simple TLS.
That could be simple TLS. Right. We already call like the Citadel agent on the node to do stuff, right? To get certs. And we normally have to wait for those certs to actually start the network anyway, right? So we're already doing this.
Yeah, except that's a different
It's a different use case,
agent.
but it has the same synchronization properties.
Is that part implemented already?
No, it currently races because there's no way to order the init container with the actual pod. There's an open issue in Kubernetes for that.
What do you mean? Because it always runs before it.
It runs before.
Right.
Right, but
you don't know about the node agent, like when it starts.
No. You know that the daemon sets are supposed to be guaranteed to be there on the node, right? The node is not schedulable until the daemon set is running, unless you're adding the daemon set after the fact, and then you can race.
Okay.
But we have an issue with racing with the init container right now.
But against what is it racing?
The Envoy pod races because it's still waiting for network config via ADS, XDS, but the actual pod itself isn't waiting.
But that's a readiness, more of a readiness.
Yeah, but that's
right.
That's for readiness.
Pod shouldn't be ready unless we signal it's ready, and we can wait for network config, get the config, and signal it's ready. Right.
But anyway, so we're obviously doing a bunch of these things today, and this might actually help us rationalize some of that if we thought a bit about it.
Can you guys share with me an implementation? I don't think I've ever seen how this can work.
So I know, for example, that in Calico, they call a node agent, a daemon set node agent over domain socket to do RBAC checks. And so the file path of the daemon that's listening on domain socket is mounted into the container.
Yeah, that's the key, by the way.
That's another, it's still a privileged action to mount a host path.
You can do that at the template layer before it's deployed.
I can do what?
You can do it as like a startup. You don't have to do that at deployment time. Like you can do that ahead of time in the template, for example, so that there's no privileged action that's occurring at runtime.
You're relying on the injection method to set up everything properly. So if you're going to discuss trust protection, you should do it at that level.
So at least in the OpenShift model, mounting a host path mount is a privileged action that normally you don't have.
If it's in the
I think what you're saying is mounting a socket, a domain socket, which would be basically a host path mount, correct?
Right.
Yeah.
So there's a host path mount.
Yeah. So that's another, at least, and I think it's the same in the pod security context model that is coming up for Kubernetes.
That's a privileged action if the mount is explicitly listed in the pod.
Correct. So the way this works is you will be you can constrain the user to what type of mount they can do, and they will all the least privileged action is to mount a persistent volume. Usually, host mounts are considered very highly privileged type of mounts, because the idea is to protect the node.
Right. But,
So why do we need a mount?
Well, we don't. We can
use
use Node IP, right? Node IP ranges are protected, right? They're slightly easier to spoof at the network level, but we can use Node IP. We know the Node IP,
Right.
so it's probably a sufficient solution and doesn't require any privilege. And for people who wanted to think about their threats a little differently, they could obviously configure their own operational behavior to mount the domain socket instead.
So the file mount was an alternative to the domain socket? Is that
The domain socket is a file.
Yeah.
Okay, so yes, the IP of the node can be injected as a normal configuration to the pod, which would then send a request to the.
Isn't it?
I think it's a downwards API in Kubernetes. I'm just checking.
That's okay in terms of privilege. And then so the Istio-pod makes a request to the Istio-pod-network-controller, and then network controller, and sending some identity, right? It needs to tell it who it is, and then from there we can move on basically.
Right.
Yeah. All right.
Oh, by the way, can you link this stock in the working group? Right now, the only thing that's linked is the GitHub repo.
Yeah, there was the presentation of that. Yes, and this is an article that we are writing. It should be out in a couple of days. But sure, I can link this document. That's not a problem.
Thanks.
Not sure.
And like it looks like we're gonna adopt this solution, right? That's why we're discussing about. So do you need help? Do you need people to review the PR? Because it's still, or do you need to, how are you?
Ask if somebody can volunteer to give us a tour of the Git repo and to understand how we should merge the code.
Yeah, we could figure that out.
Yeah.
Offline. I don't think that's pressing here.
That's what I meant.
I think that there's obviously a question about we now are going to have two solutions. Which one is going to be default? How do people choose which one? Right? Can they commingle?
You mean the two solution with the one being what we have right now, the status quo, and this being right. So that would be like that ties into our like Helm deployment and.
Right, because theoretically, there's still the open question about nodeless, right? At some point, what the hell are we going to do? This solution doesn't work for nodeless.
What is this nodeless? Like it has to run somewhere.
It runs on nodes that you can't are totally virtualized and don't necessarily have daemon sets running on them, unless you're going to have the notion of a virtual daemon, which is kind of like a thing that exists on a hypothetical node. That's all unresolved, right? But it's an open dialogue in the Kubernetes community. And Azure shipped a product, right, called AKS with, I don't know, it's either infinitely scalable node or it's something else, depending on how you look at it.
But that has large implications also on our security story with the node agent. So
anything right now that's depending on node agent, either the vendor has to pretend like the node is infinite and it just runs all the containers. And then that has an implication for the vendor has to figure out how to run the daemons.
Right. But I think at least until that becomes a reality, we can probably proceed with this as an option, right? And then
the current solution works, right?
Right. And then the other thing is not everybody necessarily wants to use IP tables capture, right? They might actually be willing to write the app to just talk to the proxy port. And then they don't need anything, right? So we have a third flavor.
Okay.
All right, so I'll contact you offline through the mailing list to see if we can set up a tour of the Git repo and start talking about how we're going to do the merge. In the meantime, we're going to design based on the feedback around these different type of synchronization.
So for a question I have for other folks who've been maintaining this stuff is, how do we think this solution compares with the existing solution for a proxy upgrade path?
I mean, well, sure, go ahead.
For upgrading an existing data plane?
Right, so let's say in theory, let's say we don't have to do rolling pod updates, but we can do rolling Envoy updates, depending on where the envoys are running or how they're running.
We still have pilot agent in the Envoy container to do that could do binary upgrades, right?
Yes, we still have that.
So that seems more desirable to me. It feels like you wouldn't want to. I mean, it depends on what your security model is, I guess, right? Do you trust the daemon to deploy the new binary to everything on the node?
Or if you're trusting the daemon to deploy the binary for a pod, then implicitly you do that, right?
Yeah.
Like, it's going to be very hard to separate the privileges then. If you give so much privilege to pilot agent, then it can download, the Bitcoiner.
Well, what is pilot agent Bitcoin at this point?
In my opinion, it is unnecessary, and we should get rid of it as soon as we have SDS.
Right.
So actually, I don't like the idea of adding more functionality into pilot agent.
Right. So really what we now have is this injection, this init container that says, hey, daemon, inject pilot with the right properties, right, into the network path for this thing. Which that basically subsumes the role of pilot agent. Right. But then it would, assuming we fix the other problems, right, if like there's health checking or readiness or other things that we have to deal with. Does that nominally also mean that there's also a way to say, hey, daemon, I want you to upgrade all the envoys on the node or these envoys, and does that actually make it easier?
So by daemon, do you mean the same daemon?
The node agent.
Like the pod network, it's called pod-network-controller here. So this guy, not the other one, the node agent for security, right?
Yes.
It would make more sense to give, okay.
I do mean that.
But I mean, is it going to be an in-place upgrade? I don't think so, right? It's probably going to be something which requires destroying the pod and doing the whole Kubernetes rolling update for the pod.
Right? Remember, we can Envoy says it can do a hot update for at least a class of traffic. You could maybe do that.
But how do you push that container into an existing pod and the binary also into the existing pod? And that's the bigger problem. It's like you can create a special mount within the pod such that you can always mount a second version of Envoy, and then the daemon can actually also exec into that container.
Well, remember that we don't really have to push Envoy into the pod except in the C group sense, right?
Yes.
So if I'm at a higher level of privilege, I should be able to start a process and make it part of the C group.
But
yes. Well, I mean, the problem is that I don't know if this will work by default in all the hosted platforms where you can run a daemon set that would do all of this stuff. It's I don't know. If it works, then great. But I mean, an easier approach would actually be to have a mount, a volume mount or something of that sort from where Envoy is actually started up, such that the daemon can decide to stick in another Envoy binary in that same mount and then literally exec into every pod and hot restart that Envoy, and the two things will automatically transfer, and there's just zero downtime for a pod. You don't even have to do the Kubernetes rolling updates, and that would also just work, right?
Right. I mean, those are kind of the same thing, right?
I mean, so do we still have any real use cases though for live binary reload? I know we have hypothetical use cases around security.
Yeah, we could probably leave aside live binary upgrade. Just the mechanics of doing actual upgrade.
Yeah, I mean, and I do think that there are some attractive properties about doing that at the node, as far as not having to deliver the container binary to every single pod, and delivering it once to the node. And well, I guess actually that already happens automatically, so that doesn't matter. Yeah.
But the other thing is obviously the node agent doesn't technically have to run Envoy in the pod.
But then that changes the security model.
Right, it just changes the security model and it changes the resource attribution model.
Well, and you basically go back to, I mean,
yeah,
I think that totally breaks the identity model in Istio as well. I don't think we can really technically do that.
We have to rewrite large parts of pilot.
You have the...
But yeah, you have to invert the handshake, right? You have the pod would still have to do the cert validation during the TLS handshake with the other pieces would have outside.
Yeah.
So here you're talking about middle proxy. If we don't inject Envoy in the pod, that means
it's where the application the network is the pod. Sorry, Envoy is no longer in the trust domain of the pod. You could still have so basically the networking would be opaque to it completely, including the existence of a sidecar. The only thing, then the question is, what's the security model? You can at least have a situation where using an out-of-band handshake mechanism, the key material is only in the pod, and therefore the handshake can only be granted if the pod basically allows it. But something running at the node level sees all the traffic in the clear after the handshake.
So how do you do that though? Because I mean, especially the inbound connections, like the pod, you have to have something running in the pod, presumably some version of an Envoy that's trimmed down that terminates a TLS.
No, we already have a mechanism for doing out-of-band TLS handshakes via an API. And Envoy already supports it. So basically, you get the hello, and you make a domain. Basically, you call another thing and say,
"Oh, the client authentication thing." Yeah, okay, sure. Oh,
so what's the advantage?
What about
of
the outbound
to that model?
Well, first of all, it's resource consumption, because like on a node, you'd have just a single Envoy running, not
no. You still have you have an
no. So you still have one in every pod, but you say it's not running in the pod. It's not a sidecar.
Yeah.
So it's per node.
No. It's one Envoy per pod, but the Envoy is not running in the pod.
Oh. So then why don't we do the full middle proxy? Because the same, like if an Envoy, if it's just able to forward the TLS, and it's still the actual node that has, still the actual pod that has the certificate, right? Then Envoy doesn't need to be for a single identity.
If we are going to run an Envoy for every pod, but inside the daemon set thing, then yes, I guess the existing model will still remain as it is, provided we just have to have a way by which, as you said, the client authentication stuff needs to be done, which we can actually go back to the pod and do the stuff and come back.
I'm not sure about this.
Should work. Well, no, but I mean,
I think that would work.
Advantage though, the advantage is that you probably have you decouple the pod from any Envoy level stuff that we go through, but it's all aggregated into one giant daemon set for which people allocate resources. Optics wise,
I think that's probably the real problem, is the resource attribution.
Well, resource attribution, the trust model becomes a little bit harder to understand. Like aligning in the pod works very nicely in Kubernetes.
It does.
It has the right semantics.
Right. I mean, that is the problem with the other solutions that are very daemon set heavy.
Well, I actually like this solution with the daemon set, even if it has, ideally, I would like to have a sort of a multi-tenant Envoy running there, right?
No, the whole point is that we avoid all that complexity, right? Like the sidecar should be lightweight and not so costly.
We put a lot of effort into making the sidecar lightweight.
Right, but that's the whole premise of the pattern.
Yeah.
Because multi-tenancy comes with harder issues. We don't have soft multi-tenancy. It's not hard multi-tenancy. We need admission control, resource isolation, and so on within that single Envoy to guarantee that every
there's so many
that would be expensive to build.
And that is a much more harder problem to solve, especially when people start asking for a harder multi-tenancy model, whereas within a single pod it's just cattle. You allocate more resources for the pod and less resources for the pod, and
all right, so let's say even if you have more Envoys running as a daemon set instead of running in sidecar, to me this is still a better model than the sidecar model. We couldn't implement this earlier because I think some of the constructs are missing in Envoy, right? But it's about how you control that daemon set pool of Envoys, right? You can apply different policies to it.
So the whole point of the security model is that you get to use a single tenant proxy that's vastly simpler, and so in theory can be faster and use less resources, because you don't have to worry about hard resource isolation. You don't have to worry about all of these things. You get better cache locality. There's all the it's a large fundamental shift in the model to try and move to per node.
I don't think we want to move to a multi-tenant Envoy. It would make the configuration story very difficult, particularly around policy.
Yep.
That's not to say that you couldn't run an Envoy per tenant,
So that's reasonable, right? And so
Mhm.
moving it out of the pod, I think is maybe reasonable depending on what your security model is and what you want to optimize for there. But I think 1 per node is not something that we really ever want to do.
No, not
Yeah, so
cert.
that
I
would be
think
1 per tenant per node then.
Yes,
Would that make
1 per pod.
more sense, right?
Or 1 per
pod per node will still be the
1
better
per
start.
identity.
Well, so you still run into resource isolation issues there. If it's one private, I can have multiple pods of the same identity scheduled together.
Sure, but why would there's no longer a security privilege problem?
No, but there is just like a so for example, like Envoy is already a bottleneck for some applications, and now I have 1 between 2 applications where I should have 2.
Can identities be dynamically assigned?
No, identities are at scheduling time.
Then it's like,
Yeah, I mean, so
Anyway,
1 per identity is the minimum that we could do and still preserve the current semantics around our security model.
Right. So let's say, for example, you had a serverless solution that ended up scheduling lots and lots of duplicate pods for the same identity. Then that might become a concern.
Yep, that I think is a very reasonable use case. Yeah.
But we still have the resource attribution problem.
Mm-hmm.
So what exactly is the resource attribution problem?
So when Envoy consumes CPU and memory, how do you assign it back to the pod so you can account for it?
Oh, okay. So for billing, basically, or all right,
or quotas or horizontal autoscaling.
Yep.
Right.
It just seems like we're doing a lot to try and defeat the Kubernetes model for benefits that aren't necessarily clear to me. Like,
no. I mean, I'm not. I just wanted to explore where there was a clear and obvious advantage.
Gotcha.
Whatever we do, we still would have to support the sidecar style model with the configuration generation for other platforms.
Yeah.
Where they cannot, let's say, for example, share this kind of a thing, and whether it's CF or whether it's a plain old VMs and so on, it will still be like a sidecar per a binary of VM. I guess in the VM, sidecar per VM, but still the way we generate configuration is treating it as a pod, and here's a whole bunch of configuration. So if anything we do ends up changing that, then we have this duality problem that we also have to generate this Envoy, per identity with all the configuration, and then at the same time, this is actually running on a VM kind of a thing. Then we also have to generate configuration in the current way, which is the full-blown configuration that we do.
Right, but for VM right now, I don't think you can run 2 services in the VM with the current model. Right,
well,
so actually, this daemon set that model would help the use case.
The packaging becomes harder because daemon set, at least you can just spin up more containers and so on. I don't know, within the VM thing, you would have to have something else that is like looking at the number of services that are assigned to that VM workload, and then based on that dynamically spins up more envoys, and we have to create whatever that's necessary to recycle the envoy, manage a life cycle of all of those envoys and so on. These are vastly easier within that single within a pod or within a container semantic, because it just takes care of rebooting the container if stuff fails. Within a VM, we have to rewrite the whole thing. We have to do it on our own, which it's just work on that front.
But I don't think in a VM you would need more than 1, right? Because it's like a VM is still a single tenant. If we go with this idea of like 1 envoy per node per tenant, then your VM would still have 1 envoy, but that envoy would be able to solve like more than 1 service.
Right, multiple services is fine. That's not a problem, right?
But it doesn't work right now because it's the same idea that you have the sidecar. So you cannot have more than 1 service.
When you say service, do you mean scheduled workload or do you mean something else?
I mean like a binary running in a VM implementing the service. So right now you cannot have 2 of these using the shared envoy.
Yeah,
right?
basically
it's a limitation of the mesh expansion.
But that's the problem with the policy. That's the problem with everything else, but not with the actual running. It's the fact that Mixer can't determine whether it's going from service 1 or service 2, right? And that is where the multiple service problem comes. It's a more inherent problem in our, the actual policy design, and not with the fact that we cannot run multiple envoys. We could definitely run.
If there's more than 1 binary, they have to listen on disjoint ports unless they're super magical, which means they can still be addressed and Mixer can still distinguish them.
No,
now whether we do a good job with that or not today, that's separate, but clearly we could.
No,
No,
because we also set IP tables in the VM. So the IP tables are set to forward, like to intercept the traffic and send it to a single service. It's not.
If we have two inbound ports, two declared inbound ports in a pod, right? We have to forward to two inbound ports. Now those ports could be listened on by two distinct binaries running in a VM, right? Or in a pod.
Yeah, actually, maybe that still works. And I don't know what the limitations are, but
the outbound side might be a little bit more complicated, but yeah.
Okay. Anyway, so
I think the network namespace will also be an issue because turning as containers, the daemon said the whole thing is going to be one network namespace, and that might actually create an issue because with two envoys listening on the same 15,000, it's not going to work. So we have to change that thing. And if every hard-coded port that we have 15,000 series port, we'd have to have multiple sets of those 15,000, 16,000, 14,000.
So coming back to the more basic part, if we have an init container that basically calls the daemon and says, "Hey, inject me," that at least gives us flexibility to control how that injection occurs without changing that contract.
Mm-hmm. Yep.
Which is right. If we want to support more than one of these models, of these injection models, then that seems advantageous in the long run.
Yeah, and I think that aligns with some of the other like identity issuance problems and that kind of stuff too. Maybe it can be simplified with that kind of model. I know that's roughly what the node agent does today.
Right.
But yeah, to your earlier point about like one abstraction to solve that set of startup problems, I think it would be nice.
Okay. So that's going to deserve some thought, but it seems like a reasonable approach. Mm-hmm. It also makes it look a little less scary to people when we inject stuff.
Yes.
Right, because all they see is the Istio init injection saying, like this tiny little binary, then all it does is talk to the daemon, which is right. So now there's a stronger perceptual separation between the service owner and the network operator, which is probably not a bad thing.
Okay. We're largely over time, but it's a very interesting discussion. So
let's start with this and take baby steps and make sure that the privilege thing is removed, and then let's see how far that takes us, and that will still give us the means, as you said, right, that we can actually.
Well, I think we need to write a doc because we're going to have to get this reviewed by some other folks. I'd like to run this by some folks in the Kubernetes networking world. And actually just in Kubernetes world in general, because this reliance on a daemon is interesting. And what's going to happen in Nodeless, I'd like to get some feedback on that, whether that's long-term tenable or whether there are other solutions out there to this permissioning problem.
And does that daemon set style help us at all in non-kube environments? I'm just trying to think, having a daemon that does that might be kind of convenient.
Certainly in managed VM environments, right, there is you most expose a metadata service where you can ask it for things. Mm-hmm. I don't know, Sri, if that would be something that VMware would ever do, right, with the hypervisor, provide an API where you could say, I want the mesh network.
Well, the mesh network is what? I mean, it's an L7 network, right? It's an underlying L4 network is VMHCI.
Well, just saying, like inject me a sidecar, basically.
Right.
Yeah.
Right. So in a world where you can't rewrite VMs or do like injection like you can do in Kubernetes, but you still want to be able to control how you turn on the feature and where, that feature now belongs in the hypervisor, right? Hypervisor is the node agent, effectively.
Yeah, but there are other mechanisms, like instead of running that thing on a VM, I mean, you can just still run it as a co-located VM, and the traffic can actually be like, intercepted and routed through this VM. The Open vSwitch thing automatically allows that kind of a stuff. So you do not actually have to run it on a VM and say inject us. Well, yeah, to your point, yes, you can have.
Well, it's not saying inject, like we wouldn't make the API inject sidecar. We would say turn on the mesh.
Yeah,
is what you would say.
Okay, and that would effectively enable the.
So like in Kube, that would mean inject the sidecar pod. right? But in VM, that could mean start the sidecar process, or it could mean some other thing, right? If you were going to try and hide it away at the node level, for example.
Yeah. And another concern that I have that we have to think about is kubelet health checking. All right, if there's no declaration in the pod for the thing to health check, and we want to health check the Envoy, how is kubelet going to health check it?
It's not.
But we want it to.
Right?
Yeah, but we need help.
Otherwise, I think
Kubelet
it's
just
going to
health
restart.
checks the container, and the container.
Yeah, but we can't
We're not even
dynamically
declaring
launch
the
the
Envoy process.
We're not even declaring the Envoy container.
in our daemon set. So I guess that brings a lifecycle problem to us. Then we have to make sure this thing is not down, and then we have to make sure this thing is back up, which is a bigger problem. Because the nicer thing about Kubernetes is that it takes care of the whole lifecycle thing. Otherwise, you're getting into this really painful thing. This whole bunch of folks and execs and managing the zombie processes, and that's a really painful thing actually. When you start looking at whether this thing has died or not, if it's not dead, and then you have to make sure that if that thing is actually forking something, make sure it's just not problematic. And when that dies, you have to reap all the resources. It is actually very painful. And the nicest thing about the Kubernetes abstraction is that if you declare it as a container, that will take care of cleaning up that stuff. And if the container dies, it'll restart the whole container. And which, if we do the daemon set where we don't declare it as a container, then we inherit the entire problem.
Yeah, and for the record, that's why
I added as a version from the pilot. I mean, this was part of the pilot agent thing in the beginning. It took us a while to stabilize with just one Envoy, and this was from the old Amalgamate days, and it took us a while to stabilize back and forth with a whole bunch of retries, backups, and that and this. And it's probably going to get more compounded if we have multiple Envoys that are dynamically being started at some.
Yeah.
But I think the daemon set also starts containers, right? The daemon set is just a thing to say run it on
Right.
one
But if you want kubelet
instance of every node.
But you have to if you want kubelet to health check them, you have to declare them in the config.
Yeah.
Well,
So if you dynamically scheduled containers, kubelet wouldn't know about them.
Of course, if you don't use the infrastructure, yes, they won't, right?
Yeah. That,
Right,
in
so
my mind, is probably the biggest downside, even more than resource attribution,
Yeah.
is that lifecycle management. And that's why I'm generally not in favor of the binary upgrade out of band of the platform.
But why, why
Which
wouldn't you
item?
declare
Well, no.
the envoys as containers in the daemon set? Why would you not?
No. So let's say we're still doing in pod, right? But now we have this init container, and it goes, "Hey node, inject my Envoy." So start my Envoy, run it, and inject it into me. Right. So it can do that, right? It can exec it into the C group, but Kubernetes won't know about it because it's not declared.
So you don't want. So you still want to run Envoy with the pod in.
Right. We don't have a container
pod,
declaration
but
in the
not as
pod.
a container. Okay, I thought you were talking about when Envoy is running in the daemon set full of envoys. No, so we're in this case.
We also lose a lot of debuggability, I think, in that world. We can't use the standard Kubernetes debuggability.
I don't think that's a big advantage. I mean, except for the binary upgrade.
Okay, so we are literally saying we are constraining ourselves to just the init container. All it does is it asks the daemon to do the privilege work and nothing else.
For now.
Yeah, I think in the short.
But we could use that as, I would say that instead of just simply saying set up the IP tables, if we find out a way by which we can have a volume mount where we can stick the Envoy that we want, and then the code in pilot agent is written such that it actually goes to /mount /envoy and boots it, then it actually provides us a nice way by which all we have to do is mount a new version of Envoy in the same volume mount. Add that file to, and pilot agent simply needs to get and the equivalent of an ioctl or some kind of a ping that basically allows it to do a nice hot restart. I saw a new version of Envoy. Let me just go and
Yeah, so that's
possible.
restart within the container. That's fine.
Mm-hmm.
Right, but restart within that container. And so what I'm saying is that for that, we can actually use this mechanism by which we share a mount. I don't know, whatever the Kubernetes term is, but such that Envoy is actually in that mount. And that actually allows people to do a gradual rollout on a per node basis, because they can actually decide that this node is going to get this mount, and then the new version of Envoy, and all the pilot agents on that node will actually start picking up the new version of Envoy and doing a hot restart of their respective Envoys, which gives that nice gradual rollout thing that we actually wanted?
Yeah,
Well,
I think this is
yeah.
possible. I've done something similar with Delph, like in Minikube. I was mounting a volume in my Minikube, and then I had Delph like in running, and the process, like the pilot compiled locally, and I was just replacing the binary basically, and restarting it, and I was getting the new binary. So that should work, right, for upgrades, if we go this way.
Right, certainly upgrade without reinjection is a useful thing that we want to get to. All right, we probably flogged this horse to death, but clearly we need a doc outlining some of the options.
And an owner.
An owner.
So I nominate Louis Ryan.
You're a funny man.
I sustain your nomination.
Yeah, I third that.
I think I'm going to have troubles once the meeting is.
Yeah, see, I'm physically far away.
Hey, Zach, how's it going?
Real busy, turns out.
Yeah. All right. Well, anyway, we need an owner for the at least reviewing what Raphael has. So, and that probably shouldn't be me.
Yeah, I can help out with reviews there.
Okay.
Raphael, I hope you're still here with us.
No, he had to leave earlier, unfortunately.
Oh, okay.
Okay.
Yes, you'll follow. Like he'll probably send an email.
Yeah, so I don't have time to show
Andrew
around the
Block.
code base. Oh, sure.
Yep, this is Andrew Block from Red Hat as well. So I'll sync up with Raphael after the meeting.
Okay, great. Yeah.
Yeah, I don't have time to show around the code base, unfortunately, but I am happy to review PRs as they come in and help out with that. But
Yeah. Okay.
Great.
Okay. So I think
Yeah.
anything
we're
more,
over time.
Louis? Oh, okay.
We'll wait till the next time.
Okay, yeah, I will definitely need a follow-up on that, right? So this is yeah. All right, well, thank you, everybody, and enjoy your lunch if you have a lunch break now, and if not, enjoy the rest of the day.
Yeah.
Bye. See you next time in 2 weeks.
Thanks, everybody.
Thank you. Cheers.